Now, I promised that I would try to make this monkey drop demo make sense. And to do that, we're going to have to travel. We're going to have to travel to a distant planet called NARANG. NARANG. That stands for No Air Resistance and No what? Gravity. Now, on the planet Narang, when you fire a bullet, it just follows a straight line like a laser beam. There is no gravity, and so it just keeps on going. Okay? Uniform motion. Now, if you fire that same bullet on Earth, you find that it follows this curved path, and that path has a drop from the Narang path. Now let's see what that drop is going to be. If I use this equation, do you recognize that equation? It's just the third kinematic equation with y instead of x, because we're looking up and down instead of left or right. Now, if I call down the positive y direction, then the distance that this thing drops at any given time is going to be that distance d on the picture. It starts out with no velocity in the y direction. And the AY is going to be positive because it points down, and I'm choosing down as positive. So this is going to be plus 1/2 times 10 meters per second every second times delta t squared. Or D is going to equal 5 meters per second every second delta t squared. Now you see that this is the formula for a parabola, and that's what we get. Now, if instead of firing that bullet horizontal, we fire it up at an angle, such that it starts with an initial vertical velocity. On Narang, it will go in a straight line like a laser. Okay? And if I look at this equation, on Narang, it's this acceleration that's zero. There's no gravity. And so it would just be this. Okay? This would be, on Narang, I would have delta y is equal to v initial y delta t. And that's a straight line. Okay? Now, on Earth, this would now be v initial y delta t, or I could call this Narang position. And this would be the drop from the Narang position. And so again, I would have this drop d that's still given by 5 meters per second delta t squared from where it would have been on Narang. Whether I shoot it horizontal or at an angle, I always get that drop 5 delta t squared. Now, let's go and shoot that monkey on Narang. You see the monkey, you fire the dart, the monkey hears the dart leave the gun, the monkey lets go. What does the monkey do? Just hovers there, it's spooky. And your dart goes in a straight line like a laser beam and hits the monkey. On Narang, the monkey gets hit because you were aiming at the monkey. Now bring that same thing to the Earth. Now, the monkey drops from its Narang position, and the bullet drops from its Narang position. That drop depends on how much time has elapsed. Now, at the time when you hit the monkey, on Narang, the monkey and the dart were supposed to be both in the same location. if both of them on Earth drop the same amount from that location, they'll still be in the same place. Because the delta t was the same for the monkey as it was for the dart when they meet. Is it not? Check to see if your neighbor understood that demo on NARANG.